Hello. This question we have already discussed some time ago. But I received a viewer's comment. He proposed an alternative method of doing this problem. So I am now presenting his solution to all of us. This is the question we discussed before. There is a triangle. This side R is equal to this side R. And this side is not horizontal, and this side makes an angle alpha with the horizontal line. This part of the side is A, and this part is B. What we want is to prove this relation. Sine alpha is equal to B minus A divided by 2 times the square root of R squared minus AB. This viewer starts this problem with xy axis. This is x-axis. This is y-axis. And then next, he calls point A, B, C. Based on xy axis, he wrote down the coordinates of A, B, C. The x coordinate of x coordinate of A, sorry, not this A is here. X coordinate of A should be 0, so it's 0. The x coordinate of, the y coordinate of A should be this side, should be this distance. So the y coordinate is using this triangle, the Pythagoras theorem. So the y coordinate, the length of this side is square root of R plus, this side is the square root of the square of this side plus the square of this side, which is this, R squared minus A cosine alpha squared. This is point A. Point B, the y coordinate is 0. The x coordinate is A cosine alpha. So you have A cosine alpha and 0. But the x coordinate is negative, so it's negative, all right. The coordinates of point C, the x coordinate should be this distance. And this distance is the same as this distance. So what is that? This distance is B cosine alpha. Alpha is here. Alpha, you draw a right triangle like this. So this is the x coordinate, which should be B cosine alpha. And what is y coordinate? Point C, the y coordinate is this. So this is this side times sine alpha. This side is A plus B. So it's a plus b sine alpha. So we have the coordinates of point A, B, C. Then from this, I can find R using this. R square what is R square? So R is, let's see his writing now. B cosine alpha squared. B cosine alpha. B cosine alpha is this side, which is the same as this side. So we are using a right triangle, which is this. Right triangle. So R square is equal to this side square, which is B cosine alpha, B square cosine alpha square, plus this side square. So what is this side? A plus B sine alpha. A plus B sine alpha is this side. So this side minus this side minus this side. Let's see. A plus B sine alpha is this side. And here, square root R square minus A cosine alpha square. Let's see this now. What is this side? R square. So let's look at A square cosine alpha square. A cosine alpha is this. R square minus this square gives you this side. And take square root is this side. He wrote down A plus B sine alpha. A plus B sine alpha is this side. So this side minus this side should equal to negative this side. Actually, this person shouldn't write this way. It should write this minus this. If you write this minus this, then it is this minus this. You get this, right? You get this side. And this side square plus this squared is equal to R squared. So this is nothing but Pythagoras theorem. So once you started with this, then just carry on. Let me move my paper up. So this is here, and then this square, you expand this square, you get this. Then the next is to expand this, you get this, and you get this line. So keep on expanding, and combine this term with that term. You see you have cosine square plus sine square, which is 1, so you get this 1. And you have this term. Just simplify it, you get this line, let's see the next line. Okay, let's understand what he is writing. This is just a simplification of this line. If you follow line by line, it's not difficult. This line is to expand b squared minus a squared. So it's b minus a plus b. And you see you have a plus b here, a plus b here, and a plus b here. So you can cancel a plus b, a plus b, a plus b, a plus b. So you have this after you cancel a plus b. Now his writing here means you divide the entire line, divide this line by sine alpha. So this divide by sine alpha here, and this divide by sine alpha, the square becomes just power 1, and you get this. Sine alpha disappears. And then this line, this person means you divide this line by something squared. What do you divide? You divide by, let me see my remark. Oh, he doesn't mean that. He doesn't mean you divide this line by something square. He means you square this line. So you square this line. So b minus a divided by sine alpha, you square it. So you get this, and you square the left-hand side, you have a squared plus b squared plus 2ab. So this is this is 2ab, and this is b squared. B squared is this squared. And then you have to square the right-hand side, you get this. And you change cosine squared to 1 minus sine squared, you get this. Then you go to the next. Simplify this line, you get this. What he was doing is to multiply out, and multiply out. And then you find something can be cancelled, so something cancelled. After cancellation, you get this. Let's understand his writing. He put down this. This means now you take square root of the left side and take square root of the right hand side. That's what he means by this label. So you take square root, you get this, and you take square root, and you get this. Once you have this, then you can solve for sine alpha. The sine alpha is this divided by this. And this is exactly what we want to prove. So we proved it. So this is his work. I'm sorry that I didn't I didn't note his name, so I couldn't tell you who suggested this way. But have rough idea he has initial B, something like that, B. So anyway, if the person has watched this, please send a message that you, the contributor of this way of solution is you. Please give your name because you need the credit. Okay, that's all for the alternative solution. Thank you for watching. And remember, whoever suggests this solution, please send a message to tell everybody that your name. Thank you very much. Bye-bye. See you next time.